All right, if you're feeling like you're getting a good grasp on this whole difference quotient thing, feel free to pause and try this one on your own. Really, only the very beginning little bit and a tiny bit of notation stuff along the way is different. So we're given function f of x equals 2x squared minus x. And, oh, hold on, I already see a typo. I didn't mean to jump right to A. I want to find f prime of -3. That's what I was really looking for. Okay, so f prime of -3. And we have a formula that tells us f prime of A is equal to f of A plus h, oops, I didn't leave myself room, minus f of A all over h. And what I didn't leave myself room for was the limit as h approaches 0 of all of that. So if I want f prime of -3, -3 is my A. So I'm going to go ahead and say, all right, I'm looking for the limit as h approaches 0. So h always goes to 0 regardless of the x value you're interested in. So we want f of -3 plus h minus f of -3 all over h. And then it's all about just going back to your function and crunching through the algebra to simplify the difference quotient. So if I want to plug a -3 plus h into my function will take it and square it, multiply it by 2, and then subtract that initial input. Ooh, I think I can squeeze in this last little bit. I'm supposed to subtract off an f of -3. So if I plug -3 in here, I'm getting 9 times 2 is 18 minus a -3. So 18 plus 3 is 21. And then I was supposed to subtract that off. So this is a minus 21. Sorry for the squeeze. All over h. Okay, so now I've actually plugged all the stuff into my function. And I just want to see, in fact, before I even get too far ahead of myself, I'd like to take the limit as h goes to 0. So if I check this out, I'm going to have to do some algebraic simplification. H goes to 0 gives me an obvious problem because there's an h in the bottom. But if you check it out, on the top, as h goes to 0, you get 2 times -3 squared. So -3 squared is 9, times 2 is 18. And then we have minus -3, so that's plus 3. 18 plus 3 is 21, minus 21, so it's a 0 over 0, which means algebra is a good thing to try. So the algebra in this case is just going to be multiply a bunch of this mess out. So I'm going to square this, which will give me a 9 minus 6h plus h squared. I'm going to distribute the minus sign through, so I'll end up with a plus 3 minus h, and then I still have the minus 21 out at the end. And I'm going to go ahead and distribute that too. So I have an 18 minus a 12h plus a 2h squared. And then I'm going to go ahead and do just a little bit of combining here. Let me snake a color so you can see what I worked on. I can combine this. 3 minus 21 is -18. And I still have the minus h. Okay. So some nice things happen here. A nice thing happens anyway. The 18s drop out. And I'm left with limit as h approaches 0 of the 2h squared minus, I do get to combine 13 h's. Okay, and I finally get to factor out my h, limit as h approaches 0 of h times 2h minus 13 over h. So we cancel the h out, and then we can go ahead and take the limit. Now that the h is gone, it finally makes sense to plug 0 in for h. So the 2h is going to go away, and I'm getting a -13. So for this function, f of x equals 2x squared minus x, it appears that the slope of the tangent line at x equals -3 is -13. Okay, so that's first part. So we now have an idea of the slope of the tangent line. And this would be a great time to check out a graph of this thing, but I have that at the bottom of the page, so I'm just going to go ahead and hold off. But if you're not asked to graph, it's still not a bad idea to go into your calculator and go ahead and see if it seems reasonable to have that steep negative slope. Okay, so the next thing I'm asked for is actually the equation for the tangent line. So what we know is that its slope is negative 13. That's not enough information to find the equation for a line. What you need to find the equation for a line is either 2 points or a point and a slope. So if I could find a point, I would be in good shape. And actually, that's not that hard to do because I know I'm interested in what's happening at x equals negative 3. So to get the slope, you take the derivative. To get the point, you just go back to your original function and you say, okay, well, f of negative 3 is 2 times 9 minus negative 3, so plus 3. 18 plus 3 is the 21 that we got before. So my point is negative 321. So if I want to find the equation for the tangent line, you can use either point slope form or slope intercept form. We do enough of this that I actually use my point slope form here more than I do anywhere else. I rarely use it for other things. Okay, so there's your point slope form. We know that our y1 is 21. We know that our m is negative 13, and we know that our x1 is negative 3, so that'll actually become a plus 3. So it looks like we get y equals negative 13x minus 39, and then I'm going to add that 21 from the left. So the equation for my tangent line is negative 13x, 21, 31 minus 18. Okay, so there's the equation for my tangent line. And again, the putting it all together part of this will be checking a graph and making sure this looks right. So let's go ahead and finally do that. So again, to find the equation for a tangent line, you'll need its slope. You'll need a point, which comes from the original equation for the function that we had. This is the curve that we want to make the tangent line to. So we need to know both coordinates of the point that we want the tangent line to hit at. Okay, so let's see if I can get an idea of what this thing looks like. I think factoring actually will help me out just a little bit. If I factor out an x, I get 2x minus 1, which means my intercepts are at x equals 0 and x equals 1/2. And then I'm interested in what's happening at x equals negative 3. So we know we have to fit the point negative 321 on our graph. Geez, we have kind of a big y scale. And this is positive, so it opens up. Okay, so let's see. I'm going to move my axes a bit. I'm going to make this my y-axis, and I'm going to make this my x-axis. See if we can make what we want to see actually fit. And let's see. 0, 1/2. Okay, so let's make these 1, 2, negative 1, negative 2, negative 3. Can you see what I'm writing? Nope. Negative 4, negative 5. Okay, and then on the y-axis, I'm going to go and make these 3, 6, 9. Oh, is that going to get me high enough? I need to get to 21. That's not going to get me high enough. Okay, so let's make them 6, 12, 18. 6, 12, 18, 24. Sometimes I can count by 6s. And then we'll have a negative 6 and a negative 12. Okay, so our function has x-intercepts at 0 and 1/2. So really close together. We know it goes through the point negative 3, what was it? Negative 321. So negative 318 is here. Negative 321 should be right in the middle. Okay, let's see. I'm going to get 1 or 2 more points because I feel like this is going to look funky. If I plug negative 1 back into that thing, I get 2 times 1 plus 1. So negative 1, 3 is on there. And if I plug in negative 2, I get 4, 8 plus 2 is 10. Okay. I think I can at least do a decent job with that. So it just sneaks down below there. And then on this side, kind of mirror that. Okay, so there's a graph of my function. And this is the point that I'm really interested in. This is my 321. So I'm claiming based on my work that the tangent line is y equals negative 13x minus 18. So I would start way down here, and then I'd go over 1 up 13. What am I at? Negative 18, so it would be negative 5 over 1 up 13. 5 is 8. 6, 12. There. And then I'd go 8 and 13 is 21. Yeah, I think it's working for me. So this is supposed to be my tangent line, y equals negative 13x minus 18. And I believe it. It looks reasonable to me. You can also check that on your calculator, but there's sort of a rough sketch to see what's going on, and it looks believable. Thanks for watching.